Hey guys, welcome to Unit 3B Section 4. So this is kind of a follow-up video to what we did with the investigation on the Hinge theorem. So this is just a quick summary of what we figured out from that investigation. So looking at the first two examples, we have XVW. Notice there's 88 degrees, and then RTS, and then there's 35 degrees. So with these two triangles, V corresponds with R because it's in between the double segment and the single segment. So V and R are the corresponding angles. Now looking at these two triangles, they're definitely not congruent, even though they have two sides the same. It's the angles in between that are different. Now notice, because 88 degrees is bigger than 35 degrees, the angle across from it, XW, has to be greater than TS. So that's what we can conclude, this part right here, because of the angle difference. The converse to this Hinge theorem is that if we know the side across from two angles, the bigger of the sides has to have the bigger angle opposite of it. So looking at this one, we have 12 on side AB for the first triangle, and then 9 for side DE on the second triangle. 12 is bigger than 9, so if we look at the angles across from those sides, C and F, we know that C would have to be greater than F because of this. Okay, and just looking at them, it does obviously look like C is a bigger angle than F, but notice that the triangles do have the same two sides here and here. It's the angle in between that we're comparing, this one and this one. Okay, they aren't congruent, so I shouldn't write an arc on both of those. All right, and that was the investigation. It's another pretty intuitive theorem. Think of like a door. The wider that you open the door, the more space, therefore the bigger the angle. So let's actually apply this theorem and write an inequality. Now an inequality, if you recall, is like a less than or greater than. An inequality is similar to an equation, but there's an infinite number of solutions sometimes. So in this case, we want to write an inequality for the possible values of x. Notice that we have 12 and 12, and then they share this side, so that's the same for both triangles. What we're comparing then are the two angles. 55 is smaller than 100, and 55 corresponds to 8. So 8 is the side, and that has to be less than the side that corresponds to 100, which is 3x minus 10. So we're just setting up an inequality the same way we would in an equation. And if you recall, when you do inequalities, you can do the exact same thing. To get x by itself, we would add 10 to both sides. We get 18 is less than 3x. Then we would divide by 3, and we get 3 is less than x, or if you did it the other way, technically x is greater than 3. Either one of these works, all right? But what this is saying is the value of x has to be bigger than 3. If it's exactly 3, if you were to plug that back in, excuse me. I see what's wrong. I'm like, that does not work. 18 divided by 3 is 6. Hopefully you're watching the video and you recognize that. No, not. Ugh. Sorry. 18 divided by 3 is 6. So 6 is less than x, where x is greater than 6. If we were to plug that back in up here, 3 times 6 minus 10, we would get 18 minus 10, which equals 8. Now, this side cannot be 8. We know it has to be bigger than 8 because the other one is exactly 8. So in order to have the inequality true, we need something that's bigger than x. We don't know the exact value, but it just has to be bigger than 6. All right. Remember, you're going to watch the next video, and then you are going to do the book problems that are listed on Schoology, or the workbook problems that are listed on Schoology for both of these videos.